Yes. Now we know few properties. What is pace? Pace. Yes. And propagation speed, media to media, it's different. So let's check that as well. But before that, so shall we see what is pace? Pace, natham kalawa. So you can see this is wavelength. Wavelength is gap between two crests or two troughs. Or you can say, so gap between two consecutive points, any two consecutive points, right? If you take these two consecutive points, still that is the wavelength. Gap between two consecutive points. Gap between two consecutive points. Gap between two consecutive points. It's same, right? Here, two consecutive points, same. Gap between two consecutive points. Here also, here also. Here also it's same. That is called wavelength. Right, now you know that. Frequency is number of oscillations. You know that as well. Speed is the propagation delay or propagation, so propagation speed basically. How this propagate over the, and next is amplitude. Amplitude means the power of the signal, and the pace is basically when you compare two signals, we take the entire round, this starting from this place to this place, we measure as 360 degrees. Here to here, 360 degrees. Okay, assume there's a wave like this. Just think there's a wave like this. And you know, gap between here to here is 360 degrees. So here to here, it is 360. So measured in 360 degrees. So if there's another wave, like this, this is second wave. So second wave, let me change the color of the second wave. That is the orange color wave. Okay, can we tell the gap between the first wave and the second wave? What is the pace? Oh, this is called the pace difference. So what is the pace difference from the first wave to the second wave? How many degrees? Can you tell? So entire this round, here to here, it is 360. මේ කෝණ එකේ ඉඳන් මෙතන නැත්නම් මෙතන ඉඳන් මෙතනටම full wavelength එකේ ඉදි ගත්තම අපි කියනවා 360 degrees කියලා. 360ක් අංශ. මෙතන ඉඳන් මෙතනට. එතකොට මෙතන ඉඳන් මෙතනට කොච්චරද? What is the gap between these two waves? Yes. Divide and tell.
90.
Yes, it's 90. The pace is 90. How it came 90? Because here මෙතන ඉඳන් මෙතනට ගත්තොත් it is 180. මෙතන ඉඳන් මෙතනටමනේ 360 වලින් භාගේ 180. 180 වලින් භාගේ 90. It's 90. So that is called pace difference. So pace is critical, right? Pace, to identify pace, at least you should have two signals. Otherwise, you cannot tell about pace. හිතන්න මේක විතරක් තිබ්බා කියලා. You cannot tell pace is 90. You have to compare this with some other wave to tell the pace. Pace is basically the angle or the disposition between two waves, right? Let's see this in a better image. Pairs of signal. So rather than, okay, this one shows better picture. So the total, the full round is measured in 360. 0, 90, 180, 270, and up to here, again 0, you can say 360. Right? You can see here, from here to here, half, it is 90, here to here, another 90, here to here, 270, here to here, another 90. So gap between two waves is basically measured. This is measured using pi. Pi is this thing, right? Here, gap between our waves is, as you said, it is 90. That is the pace difference, right? Here you can see Phase difference. Is there any phase difference in these two signals? First two signals, is there any phase difference? Or same phase? මෙතන තියෙන signal දෙකේ phase difference එකක් තියෙනවද same phase?
Same pace.
Same phase. But here you can see there's a phase difference because there's a gap. That gap is 90. Okay, out of phase. So this is called in phase. The second one is called out of phase, and that is what we explained here. So I need to add this image too. So this has 90 degrees phase difference, right? But before learning that, we need to add this phase one also. This is the phase angle, right? So this is the last thing that I want to add to your note. Phase or the angle of the signal, it is measured relatively. Phase relative angle is relative angle when comparing two or more signals. So that is my text. But if you search internet, there are like standard, there's a standard definition. So let's see this standard definition also. So that is phase is the phase inverse relationship here. No single sentence definition. Phase of signal definition. So let's search for definition, but here no. Yes. Anyway, so let's go to my one. So that's easy for you to remember. That is not a property of a signal, right? So please remember, this is not a property of signal because you have to compare two signals to get this property. Right. Here between these two signals, you can see the gap is or phase is 90. In between gap is 90. Please add this to the note, and with that, so I need to add another one, the propagation speed. So let's discuss about that as well before finishing the class quickly. Right, so to show that, I'm using another animation from the Colorado University. So that is related to light transmission, but can be applicable. It is also applicable in learning about these signals. Directly, it's not related to waves, but so let's light and radiation, but still related to the propagation delay. Okay, when wave is basically, light is also a wave, right? Light is also a wave. When wave is propagating from one media to another media, so here you can see the first media is air, the second media is water. When light is transmitting from the first media to second media, it's bending. The reason behind this is just slowing down. You can see. Right? This is the reason. Just see the signal, just observe the points. Right? Just observe the points. You can see the signal, this point. This left side point touches water first. මේ වම් අත පැත්තේ තියෙන point එක වතුර ඉක්මනින් හම්බ වෙනවා. දකුණු අත පැත්තේ තියෙන point එක වතුර හම්බ වෙන්නේ යාට පහුවෙලා. එතකොට වතුර හම්බ වෙනකොටම මොකද වෙන්නේ? It will slow down because water is another media. Air is one media, water is another media. When it touches the water, it will slow down the wave. But here, in the other hand, when it touches the water, that will slow down. But since this corner is slowing down first, this will bend the light. I think you have experienced this when you put your legs into water or water bath or swimming pool. You can see your legs are bending from the middle. එහෙම එකක් පේනව නේද? කකුල් දෙක වතුරට දැම්මම නිකන් කකුල් දෙක කැඩිලා වගේ පේනවා. හේතුව, so we see everything because of light. This light is bending in the water, not in the water, even in glass it bending. It will slow down. When it slow down, what will happen? It will bend. And portion of light is also reflected. This is called refracted. Refracted light and reflected light. Refracted light is bended one. The refracted one is the one which goes out because of, so you can measure this intensity, right? Refraction is around 27% is reflected. So if you angle this more, you can see the reflection is more. Reflection is more. අර sunset එකක් බලද්දි නිකන් පේන්නේ ඇහැට එනවා ඇහැ අර නිලංකාර වෙනවා වගේ පේන්න ඕන ඉර බහින වෙලාවට. ඒ දිහා කෙලින් බලන්න බෑ. Because this intensity is high. But if it is like this, then intensity is low. This is how you see this eclipse. එහෙම බලන්නේ මෙහෙමනේ. වතුර බේසමකට වතුර දාලානේ බලන්නේ eclipse එකක්, solar eclipse එකක් එහෙම තියෙනවා. සූර්යග්‍රහණයක්. Because you can get only 5% of intensity. So here you can see the refraction. So this is refraction in glass, this is refraction in water. Right? Why this refraction happened? Because in different media, the propagation delay of wave will be different. එක එක media වල එක එක speed වලින් තමයි light එක යන්නේ. So that is called the propagation speed. Hope you understood that point. Did you get that point? Hello?
Yes.
Okay. So just go through this. I'll send this link to you. You can also test this, experience this, and see how it's changing from media to media. What is refraction? What is reflection? You can learn further. But this is best if you are learning physics. But this is not physics, this is IT. So just knowing these points will be enough. So what is? Just knowing the topics, knowing the basics will be enough. No need to go deep. But if you really want, you can study further. Okay, with that, I'm going to stop for today. Let's meet in next week. Just take a screenshot of this as well. Let's discuss in the next week about some more topics. Okay, good night.
Thank you, sir.